the same
Oh,
link
it's not the same
anymore.
URL. Okay.
Yeah.
You can even just do it on this. Is this? Do you have speakers on your thing?
Now we might get into feedback hell pretty quickly there.
Oh yeah, if I go in surround, you would really get that.
Here, Paul, I'm sending you the link.
Okay.
We went in and out, so I think that if you go to this here,
Okay.
so I just emailed that to you. I hope that works.
Okay, I'll check it out here.
Oh, here we go. That should be it. Okay.
Actually, on the screen, can you see my
Yep.
pointer?
I can. It's faint. I think that
Okay.
is something that may be able to be improved, but
If you have more powerful pointers, I guess. Right? I wouldn't want to burn your screen there. I guess it's the chapel.
okay. So this does have a sound.
It's
I think it does. That this down here
and it's working.
tells
or-
you. Yeah, it's moving.
Okay.
You can hear us. Great.
Okay, great.
Okay, so let's. I mean, the confidence monitor. I feel like we're pretty confident in the confidence monitor.
That's good that we have confidence in the confidence files.
That's right.
There I am. And myself.
Let's get out of that.
It would be great, Paul, if is Paul right? It'd be great, Paul, if you could try and make a comment as well in the chat, see if we can see it. So is the reason that you're setting it back up because the chat window stopped working or something? Like,
The chat was referring to the previous
okay.
stream, so it was effectively a new stream.
We can hear.
Yeah, that's not bad. So I just typed in here a new stream. You can see it there. Oh, but it's what's that? We don't need two of those.
I'm going to tell you about the Igloo capture technology today. Hey, hey, ho, ho, I can hear all. It's good to go.
Do you want to hear it on the other side? I can just stand up there and talk about the Pro.
Just so I can hear the volume, because
Yeah.
I'll be worried I usually shout too loud.
And that's something we would control for on the day of. You know, we want to make sure that the adjustments are clear on all sides. And I don't have the confidence monitor up, but we'd want to make sure that the slides, we weren't blocking important parts. So with our other speakers, we'll probably want to give them half hour or so. To come in and test everything.
Yeah, that's good. Very good quality.
Yeah.
And visual quality.
Yeah, we're happy with the visuals. HTC is just good enough. Like 4K film will work out. It's not on the market yet.
Okay, welcome to the Large Hadron Collider. Now, this is supposed to help us find basically the Big Bang particle, the dot particle, so to speak. And what does FRIB stand for? Facility for Research, for Rare Isotope. I forget what the B stands for. But what I really would like to know is how close is this working in conjunction with the ERT in France, which are trying to build a tokamak to try to create fusion energy. How can these two be designed to work together? How can they collaborate? That is what we're going to discuss today.
Okay, good afternoon. So my name again is Daniel Hayden. That was Paul, who's going to be taking my job after I finish here, and we'll give you a tour around the Large Hadron Collider. So we're trying to see if there's an echo in the voice as we talk about this. I'll try and speak at a slightly lower volume as well to see if that makes any difference with the echo. And I'll also speak at a much higher volume so I can see if that makes a difference with the echo as well.
Yeah, keep talking.
Okay, I've been asked to keep talking. I might as well just then start giving a little bit of this, which I can just do time and time again. So this is the Large Hadron Collider, which is at CERN in Geneva, Switzerland. You can see a nice aerial picture here with the Alps in the background. Here is Lake Geneva and the airport where you would fly into. And this is the accelerator tunnel we use to accelerate protons very, very close to the speed of light. About 99.99999% the speed of light. And the circumference of this tunnel is 27 kilometers in circumference. This is what it looks like underground, about 100 meters underground. You have the beam pipe where the protons pass along with magnets to keep on bending it around in a circle. And what we do is bring the protons together to collide within some experiments which act like massive digital cameras, essentially. And I work on one of them called the Atlas experiment. It's not changing slide. It's not changing slide for some reason.
Oh, really? Okay. Might just be, I haven't clicked on this. Sorry?
There we go. Okay. So I'll skip this now. This is the Atlas detector. It weighs over 7,000 tons. It's 40 meters in length, 44 meters in length, and 22 meters in diameter.
Yeah.
You're thinking to affect the echo? Or?
Yes, we can source some more sound.
Yeah, we're just thinking of making sound sinks. Improvise sound sinks right now. I don't think that the gain helped very much.
You would want to turn down the gain, though.
Yeah.
Hey, silly, but this is physics. Is it just the position of the mic? If we get the mic closer to me, does that mean less of the reflections come back into the mic?
Probably.
Yeah, he's got the gain all the way down.
Is there a way that we can move this whole thing just closer?
Actually, let's take a look at the settings for the mic too.
Move the gain all the way down.
Okay. I'm going to switch it to,
There is no echo in the room here. You can even hear it when we're speaking, right?
Right.
So I'm not surprised that it's picking it up.
I know it just sounds worse there than here.
Okay.
But I just switched the setting on it so that it's not doing full omnidirectional. And it's now doing basically as if we're having
A thin beam.
a conversation. Like if I'm here, you're here. It's only going to hear us, but not this,
So wherever I am, I should talk directly towards the mic, though, I guess.
which is right behind this. So
Okay. Do you want to see if it makes a difference then?
Yes.
I'll keep on talking. And,
yeah, I'm going to listen to it like that.
Okay. Okay, as I understand it, Paul has just narrowed the field of view to the microphone, so you can see if it affects the effect of the echo at all, as it should only be receiving a beam of sound directly from me, and we can see if this makes any difference at all to the echo.
I'm sure that it's not good to listen to these things.
Yeah?
Great.
It sounds like it's as if you were doing a presentation in a hall, but it's you. It's not
It's not
it's
reflecting. Okay. Still have to learn about where to stand. I think eventually I'm gonna have to put some string down or something to tell me. 'Cause
Well,
that-
we have the. Do you want to? I mean, that's why we put down the blue tape that we have so far. Do you want to start blocking it out for yourself?
yeah, I mean, I'm just going to imagine a straight line from that blue tape. That is a good distance, but then it goes out to here, goes to there, and I guess it goes to there as well then.
And I'll cue this back up over here.
Even just a small bit of tape. I don't want to tape up your floor.
it's carpet. It's meant for that. Okay. Would you grab that in?
Sure. So I know that it's from here is fine.
Sort of line too that you don't want.
Yeah. Because I know that I'm too close if I
Yep.
do it otherwise. And then that goes to there. I think, yeah, do that.
And here the dead center is going to be right about here.
I wouldn't want to go any further past this line, basically. Right foot not past the grey.
Yep.
And then similarly on this side, I think I don't want to go past there.
Okay, so nothing like that.
If we want to be perfectionists, we can do it on this grey line.
We're gonna do
it.
We will be perfectionists.
There we go. Okay. Very nice, thank you. This is kind of good distance. Oh, okay, it's back on this. Oh, am I controlling the? Oh, I think we're on.
Oops, thanks. There we go. Should be better.
There we go. Okay. Okay, should we just do a full dress rehearsal of a few seconds then?
Yeah, sure.
And then we can see. I wonder if we don't close the stream, you can go back. What? I don't know. I don't know what happens. We can figure that out later, I guess.
What? So what do you mean?
I mean, so that I could hear it back myself after we've finished, kind of thing. I wonder if you don't close the stream, because there, Paul could go back and watch an earlier part of the stream while it was live. But I think when we turned off the stream before, it automatically moved him onto a new video.
Is that true that it's you? Yeah, I don't know. Like, okay, if you pick it up at like minute 5 and you're like, oh, I want to listen to minute 2.
Yeah, that's what it seemed that we could do,
Okay.
but it still doesn't seem to save it afterwards. Okay, well, we can investigate that, but at least this setup looks pretty good now, I think, right?
It might be a little. Let's see. I wonder how it looks over here.
Yes,
It
actually,
looks
if you
fine.
go in there and I'll speak, can you also tell me what the video looks like when I put the video on? So this is me giving my talk, and I'll go through the Atlas detector, and then I will show a video of a collision. So this is actually an animation of the protons coming down the beam pipe and then going into, this is the Atlas detector we just talked about. We bring them together in a collision in the center, and then we look at all of the particles that come out, measure their energy and direction. And I was beyond the end there, but you can see. And this is what we tried to add together to work out what happened in the collision at the center. A very, very high energy, a number called 14 tera electron volts. Okay, so what I'm interested in is how did that video come across?
It does. And then it takes a while to render them. So
I can put my mouse back up now just for safety of everyone.
we end stream here.
So yeah.